Okay, the other day we left off with the energy forms, like electrical, mechanical, that kind of thing. Today we're moving on. You need to know the difference between potential and kinetic energy. Potential energy is energy of position. It is anything that is not moving. Kinetic energy is the energy of motion. If it is moving, it is kinetic energy. You need to copy these two bullets, and you need to know this picture. You're going to see this bicyclist as he's going up the hill. That's kinetic energy. At the very top of the hill, there's a moment or a brief pause, just a few milliseconds, where the bicycle and he is no longer, or she, are no longer moving, and that is potential energy. And then as the cyclist goes down the other side of the hill, that is kinetic energy. Okay, elastic and chemical potential energy. You need to copy them both. Elastic energy is energy that can be stored by something that is stretched or compressed, like a rubber band or a bouncy ball, a spring. All of those are elastic energy. Chemical energy is the energy that is stored in chemical bonds, like food. When you eat your food until it breaks down into your body, that's potential energy. Okay, you need the first bullet only. Work is measured in joules, Joules. Okay, energy is also measured in joules. So make sure you know work and energy are measured in joules. Let's see, what do you all need here? Okay, kinetic energy, you need the second bullet and the third bullet. So this one here and this one here. Now, with kinetic energy, the faster an object moves, the more kinetic energy it has. Kinetic energy depends on both mass and velocity or speed. To calculate kinetic energy, it's actually a math equation that we'll be doing lots of in class with calculators. You need to know that it is mass times velocity squared divided by 2. We have a couple sample problems here. Okay, they're all word problems. You do not need to copy this, just pay attention. Okay, the word problem would be, who has more kinetic energy? An 80 kilogram man moving at 4 meters per second, or a 40 kilogram boy moving at 8 meters per second. To work that out, we would take the mass and velocity of the man, so 80 kilograms, oh, that should say kilometers, sorry. Okay, 80 kilograms times 4 meters per second squared, okay, divided by 2. And that answer is 640 joules. The second part of it, after the or, is your boy. A 40 kilogram boy times 8 meters per second squared divided by 2 is 1,280 joules. So who do you think has more kinetic energy? It's the boy, okay? Even though he weighs less, he has more kinetic energy. Okay, here are 2 more problems. I want you to do these on your own, and we will look at them in class on Thursday. Okay, potential energy. Honestly, the only one you really need is the bottom one right here. Okay, the third bullet. Potential energy is an object that stores the energy. It can be based on position, like the stretch rubber band or a wound up watch, anything held up high. Or it can be stored in a battery as chemical potential energy, in fuel until it's burned, or stored into the nucleus until it is split. Gravitational potential energy. You need this first bullet. Actually, you kind of need it all. I'm sorry. This one you need it all. Okay, gravitational potential energy is potential energy that is dependent on height. The higher up an object, the more gravitational potential energy it has. The more mass, also the more gravitational potential energy. GPE is gravitational potential energy. And there is a math equation with this also, which I will give you calculators. It is mass times 9.8, that's what gravity is, times height. So mass times gravity, 9.8 times height. Okay, we're skipping that. Do not copy this. You do not need to copy this. Okay, all energy types can be changed from one form into another. An electric motor is an electromagnetic energy that changes to mechanical. A battery is chemical potential energy that changes to electromagnetic. The sun is nuclear energy, which changes to electromagnetic energy in the form of the light coming out, to heat when it strikes the earth. Okay, there's lots of other forms of energy. Like I said, you do not need to copy that. This one you need to know, so you need to copy this bullet. The most common energy conversion involves the changing of potential energy to kinetic energy, or kinetic to potential. So something that is still and then starts to move, or something that's moving and then stops. That's the most common energy conversion. Okay, do not copy this one. Do not copy it. All forms of energy can be converted to other forms: kinetic to electric, electric to light, electric to mechanical, chemical to heat, heat to mechanical, mechanical to electric, electric to heat. Just like our lab that we did today with the gizmo. This is the same type of thing. You need the first two bullets. So you need this bullet and this bullet. The law of conservation of energy states that energy can neither be created or destroyed by ordinary means. It changes into another energy form. So energy can't just disappear. It has to change into another form. Okay, Albert Einstein's theory of relativity kind of goes into this. It's directly related. It says that mass and energy are directly related, and energy and mass are interchangeable. In other words, the smaller something is, the more energy it creates, such as the atom. Let's see, you need the first bullet and the third bullet. So the first bullet right here, a force is required to change the motion of an object, and power is the rate at which work is done and the rate at which energy is consumed. And that is it, folks. Have a good night. Remember, bring these notes to class. If you do not bring the notes themselves to class, you do not do the lab that we are doing.